Welcome to our video lesson on the order of operations with rational numbers. We've looked at the order of operations and why it's in the order it's in. Remember, it goes from most powerful operation to least powerful operation. And we've looked at operations with rational numbers, so now we're going to combine the two together. We're going to do 4 examples together. This first one here is working with decimals. All right, remember we're going from the most powerful operation to the least powerful operation. So in this expression here, we need to figure out what our most powerful operation will be. Is it going to be addition or division? Hopefully you'll see that it's division. It's more powerful than addition. So I'm going to divide 5 and 1/10 by 1 and 7/10. Now, I don't know how to divide by decimals like this, so the first thing I do is multiply both my divisor and my dividend by 10, which moves my decimal place 1 spot to the right and does not affect my quotient or my answer at all. And now I'm dividing 51 by 17. Alright, I know 17 is really close to 20. You could round it up to 20. And 51 is very close to 50. So 20 could go into 60 3 times. So my guess is that 17 times around 3 should be around 51, maybe a little less. So I'm going to check it over here. What's 17 times 3? Well, 3 times 7 is 21, and 3 times 1 is 3, plus 2 is 5. So 17 times 3 is actually 51. So that means I can write my 3 up here, put 51 here, I subtract them, and I get 0, so I'm done. So that means we can rewrite the first part of our question over here as 4 5/10 plus 3. That became a whole lot simpler in the next line. Alright, for my next operation, I'm going to be finding the sum of these two numbers. So I have 4 5/10 plus 3. Now I have to line up my decimals with addition. So 5 plus 0 is 5, and 4 plus 3 is 7, and I write my decimal point there. So this is equal to 7 5/10. And that's it for our question. We're actually done number 1. Let's look at number 2. In number 2, we have a lot more options for our operations. We have subtraction, we have multiplication, and we have an exponent. So remember that you can remember your acronym, so BEDMAS or PEMDAS or GMA, whatever you prefer, or just remember it goes from most powerful to least powerful. So our most powerful here is going to be the exponent. So the first thing I'm going to do is this one right here. I have 0.5 times 0.5. 5 times 5 is 25. And 5 times 0 is 0, plus 2 is 2. Put a 0. 0 times 5 is 0, and 0 times 0 is 0. Then I'm going to find the sum. 5 plus 0 is 5, and 2 plus 0 is 2, and then I have my 0 here. Now I'm going to count the number of decimal places in my factors. I have 1, 2, and add that many to my product. 1, 2. So that means 0 5/10 squared is 0.25. So my next line would say -5 8/10, 5.8, minus 3.1 times 0.25. Alright, for my next operation, I need the next most powerful operation. So we have subtraction or we have multiplication. Well, multiplication is more powerful than subtraction. So my next operation is going to be this one right here. 3.1 times 0.25. Now I'm going to write it this way, but you could write it the other way as well. It's just a little bit easier if we do it this way. Okay, 1 times 5 is 5, and 1 times 2 is 2. 1 times 0 is 0. I add a 0 here. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. and I find the sum. 5 and 0 is 5, 2 and 5 is 7, 0 and 7 is 7, and then I add my decimal places. I have 1, 2, 3 in my factors, so I'm going to include 1, 2, 3 in my product. I'm going to have to add a 0 out here, front here. So I have 0.775, or 0 and 775 thousandths. So in my next line here, I keep the 5.8 because I haven't done anything with that yet, minus, haven't done anything with that subtraction sign, but I replace this part here with 0.775. Alright, now I have subtraction and it's my only operation left. We are subtracting with integers. Now I hope you remember that subtracting with integers is the same as adding the opposite. So what I'm going to do here is rewrite this as an addition question where I'm adding the opposite. So this is equal to negative 5.8 plus negative 0.775. I'm going to add my brackets here to make it grammatically correct. Okay, here I'm adding two decimals with the same sign. So remember, same signs, we're going to add them and keep the sign. So in this situation, my sign for my final answer is going to be negative because both of these are negative. And then I need to find the sum of these two numbers. So I'm going to add 0.775 plus 5.8. I'm adding two zeros here just to fill those spots. 5 and 0 is 5, 7 and 0 is 7, 7 and 8 is 15. Add my decimal place, and 5 and 1 is 6. So that means my final answer here is negative 6 and 575 thousandths, or negative 6 and 6.575. Alright, let's look at our third example. In this one, we're dealing with fractions. Again, we're going to follow our order of operations. So we go from most powerful to least powerful. The most powerful operation we have here is this exponent. So the first thing we're going to do is this part of the expression. So I'm going to multiply negative 1/2 times negative 1/2. When we multiply a negative times a negative, it always gives us a positive, so I know my product will be positive. And then I'm just going to multiply the numerators and then multiply the denominators. So 1 times 1 is 1, and 2 times 2 is 4. So that means that negative 1/2 squared is actually equal to positive 1/4, which is very interesting. So we have 2/3 times 1/4 plus 5/6. Okay, for our next operation. Next, we need to do the next most powerful operation, which is multiplication. So now we're going to focus on multiplying 2/3 times 1/4. So I have 2/3 times 1/4. Well, with multiplication, I just multiply across. So 2 times 1 is 2. And 3 times 4 is 12. Now I can simplify this. 2/12 is the same as 1/6. So I'm going to use 1/6 and write 1/6 here to replace my multiplication, plus 5/6. Well, the nice thing is, because we simplified our product here, we have the same denominator here. We already have a common denominator of 6. So we can keep that denominator of 6, and I add 1 and 5 together to get 6. Now 6 out of 6, that means we have a circle, and we divide it into 6 parts. And we have all 6 of those parts. So that's actually equal to 1 whole. So this whole expression up here is actually equal to 1, which is really funny when you look at it. You don't think that's going to be equal to 1, but it really is. Okay, let's look at our final example together. There are a whole lot of brackets and parentheses in this one. Now remember, mathematicians included brackets so that they could change the order of operations to give them that flexibility. So whenever we see brackets, that's what we're going to do first. So right now we're going to just worry about what's inside these brackets here. And everything else is going to stay the same. So I'm going to copy it out because I know none of this is going to change. Okay, now I need to focus on this. I have negative 5/4 plus negative 1/10. Now in order to add fractions, I need a common denominator. What's my common denominator of 5/4 and 1/10 going to be? Hopefully you're thinking it's 20. Okay, how do I get from 4 to 20? I multiply by 5, so I'm going to do the same thing with my negative 5, and negative 5 times 5 will give me negative 25. And here I have, how do I get from 10 to 20? Well, that's times 2. So I have negative 1 times 2 would be negative 2. Now here I have negative 25/20 plus negative 2/20. And that would be equal to negative 27/20. Now I can't simplify this. I could rewrite it into a mixed number, but I don't want to do that because I know I'm going to have to do more work with it over here. So I might as well leave it as an improper fraction. So this is divided by negative 27/20. Alright, the next most powerful operation we have here is division. So now I'm looking at this part of our question here. 9/4 divided by negative 27/20. Now, to divide, we're actually going to multiply. So we have 9/4 times the reciprocal of negative 27/20, which would be 20/27. Now here we have one positive and one negative, which means our product is going to be a negative number. 9 times 20. Well, we know 9 times 2 is 18, so we would just add a 0 to that and it'd be 120. But if you want to see it, I'll do it. 9 times 0 is 0, and 9 times 2 is 18. So here we have negative 180 over whatever 4 times 27 is. Now using estimation, 27 is close to 25, and I know that 25 times 4 is 100, so I think this is going to be about 100. So 4 times 7 is 28, and 4 times 2 is 8, plus 2 is 10. So I get 108, which is close to what I estimated, around 100. Now before we put this back in for our next line in our original question, I want to simplify it, because this is a really hard number to work with. And I know that both my numerator and my denominator have to be divisible by 2. So let's divide both of these by 2. 180 divided by 2 is going to be 90, and 108 divided by 2 is going to give me 54. Alright, I need to keep working with these. You might see, oh, it's divisible by 2, so I'm going to divide it by 2 again. But when I look at this, I see that, oh, they're both divisible by 9. So my first move is going to be divided by 9. You can do it either way, and you will still get the same answer. So negative 90 divided by 9 would be negative 10, over 54 divided by 9 would be 6. Now I can still simplify this. I'm going to divide both my numerator and my denominator by 2. Negative 10 divided by 2 is negative 5, and 6 divided by 2 is 3. And that's as simple as it can get. So my next line is going to say 3/8 minus negative 5/3. Now remember that subtraction is like adding the opposite. So instead of writing this as subtraction, I'm going to write it as adding the opposite. So here I have 3/8 plus 5 over 3. Now I need a common denominator in order to be able to add these two fractions together. So my common denominator, I should change colors, is going to be 24. How do I get from 8 to 24? Well, that's times 3. So what's 3 times 3? 3 times 3 is 9. So I have 9 24ths plus, how do I get from 3 to 24? That's times 8. So plus 5 times 8, that would be 40. So I'm going to be left with 49 over 24. Now I need to simplify this now I'm going to rewrite this improper fraction as a mixed number. To do that, I divide 49 by 24. And 24 can go into 49 twice. 2 times 24 is 48. 49 minus 48 is 1. So I get that this is equal to 2 and 1 24ths. That's all for our lesson today. If you need to, go back and rewatch any part of this lesson. That's part of the reason I make these videos. I hope that you're feeling pretty confident with your ability with order of operations and rational numbers. That's all for now. I'll talk to you later.